All right, example 5. We've got some more equations here. The first one is an exponential equation. But we've got 2e to the x's here, and they're not the same. So it's not like we can just combine like terms, because e to the 2x is different from e to the x. Does that look like anything you've maybe seen before at all? Maybe? No? Okay. What if, thank you for the honesty, I was just asking, if anybody saw, what if I started to do this? Where do you think I'm headed with this? Dang. So check this out. E to the x times e to the x. What does that equal? E to the x times e to the x. E to the 2x, because we add exponents, right? Same base, we add their exponents. X plus x is 2x. Okay? What multiplies to give us 2 and adds to give us negative 3? Negative 2 and negative 1, all right? Let's check it. FOIL it back out. E to the x times e to the x, we just covered with e to the 2x. We've got a negative e to the x on the outside and a negative 2 e to the x on the inside. Those combine to give us that negative 3 e to the x in the middle. So, what's the next step in solving by factoring? After this, what do we do? Set them equal to 0. E to the x minus 2 is equal to 0. E to the x minus 1 is equal to 0. So we solve. We've got e to the x equals 2. So what does x equal? What do we do to get x by itself? Logarithmic form, natural log of 2. So for the other one, e to the x equals 1. What does x equal to there? 0, right? If you write in logarithmic form, it's the natural log of 1, but any log of 1 is 0. So those are our two answers. Check them. It's an equation. You should always, always, always plug it back in to check. So we've got e. Good thing is it goes ahead and starts a set of parentheses for us. We've got to make sure we close them. So when we're plugging in the natural log of 2, we close the parentheses for the 2, and then we got to close the parentheses again for the exponent. Minus 3 e to the natural log of 2 plus 2 gives us 0. Okay, and if we check 0 as well, e to the 2 times 0 minus 3 e to the 0 plus 2, it gives us 0 as well. Okay? So those are your two solutions. All right, so we can factor with e to the x. Who knew? Who knew? All right, let's look at b here. Okay, b, we've got the log of 5x plus the log of x minus 1 is equal to 2. What do we need to do first? Combine the logs. Okay, I think that y'all went ahead and did the examples like that, or did the practice problems like this yesterday, but it's a good review right here. Okay, so we combine the logs. What comes next? The variable is stuck inside the logarithm. What do we do next? How do we get it out of the log? Exponential form. What's the base? What's the base? 10. Because there is no base. It's understood to be 10. 10 squared equals, I'm going to go ahead and multiply that out. 5x squared minus 5x. Okay, I went ahead and distributed the 5x. Excuse me. So we have 100 is equal to 5x squared minus 5x. What do we have to do here to solve this? What kind of equation is it? Quadratic. So everything's got to be equal to 0 on one side. Technically, right here, you can divide everything by 5. Because everything's divisible by 5. You can go ahead and do that and then get it equal to 0. Or you can get it equal to 0 and then factor out 5. Either way, it does the same thing. Okay? So we've got x minus 5 times x plus 4. So we get x equals 5 and x equals negative 4. Are both of those valid solutions? Which one is not? Negative 4 is not. When we plug it in now, it's not the fact that it's negative. Okay, it's not just the fact that it's negative. It's because when we plug it in, 5 times negative 4 is negative 20. We can't take the log of negative 20. Okay, if that had been the log of negative 5x, it would have been okay, because negative 5 times negative 4 is positive 20. So negative 4 is extraneous. 5 is our only solution. And again, there's no reason not to check that just to make sure. So we know there's not a problem with it being negative, but did we really do everything correctly? Okay. And just plug it back in, make sure it equals 2. So we're good. All right. I'm going to go ahead and tell you, every single time I give people a test on the exponential and logarithms test, I have people that can't do a problem like this because they forget that from here, I just put it in exponential form. When your variable is stuck inside the logarithm, the only way to get it out is to put it in exponential form. This is different from, let me see if I can find one real quick. This is different from here. Okay, this example right here, when the same log is on both sides, then you just set what's inside the logarithm equal to each other. Okay, but if you don't have a log on both sides, you have to write it in exponential form. Okay, when you don't have a log on both sides, you have to write in exponential form. But when you do have a log on both sides, you just set them equal to each other. And always, always, always check the answer. I had people that don't check the answers. Or they check the answers and they don't check them correctly, so they throw out stuff that they're not supposed to throw out. You have to be careful with parentheses. Okay? All right, so I've got 2 practice problems for you to do here, and then we will look at a word problem.